Welcome to your second class with me. I'm Dr. Sumit Bhatnagar. I'm a physics faculty at Prepaze. Before starting today's session, let me briefly explain you what is Prepaze and why you should join it. So Prepaze is an online tutoring platform where you can find teachers from all over the world, and you can choose your own teacher and understand at your own pace at the comfort of your home. You want classes from here, you can definitely go to the website and check the links, take a free trial as soon as you can. So let's start today's topic. So today we will be continuing our discussion on kinematics. All right, studied about distance, displacement, then we did discuss about the speed and the instantaneous speed, average speed, instantaneous velocity, all those things we discussed. Today we'll continue on that topic. From continuing from there only now. So we discussed that instantaneous velocity, the velocity at a particular instant, and if the ds and the displacement and time graph is given to you, how you can find out the velocity by finding out the slope. From that method, you can just find out what is the instantaneous velocity. So now, until now, what we have discussed is that if the particle is moving, let's say in a uniform motion. So let us discuss important thing over here. So this term you might encounter in your questions or in your books. Uniform motion. Now, what is a uniform motion? Is that motion where there is an equal change in position of a particle at equal interval of time. All right, there's an equal change in the position of a particle at equal interval of time. That means in a uniform motion, what happens that velocity is constant. So whenever a uniform motion word is given anywhere, you must directly tell that the velocity of that motion is constant. How a graph of a uniform motion will look like? You can see from the definition what I told. If you have a position and time graph, that is a displacement time graph, and it is something over like this, a straight line, because there is an equal change in the position. So suppose let's say I'm going from time t over here to time t2, right? So you can see over here that there is some change in the position, which is basically given by what? S. Let us say it is given by S. All right. Now, if I go from 2t to let's say 3t over here, then the position change will be S. So there is an equal change in the position and equal interval of time. That is obviously a straight line. Basically, if I talk about ST graph, that is a displacement time graph. And how will a velocity time graph look like? Since velocity is a constant, it will be a straight line like that. That is a constant velocity. All right. So this was basically about equal motion of a uniform motion. Basically, if now suppose the motion is not uniform, then what basically we need to do? We need to introduce one more term, which is known as acceleration. So the third important in this topic is the acceleration. So what is acceleration? Acceleration is A. We define it by letter A is equals to change in velocity over time taken. That is basically delta V over delta t, change in velocity. Okay, now what will be the unit? Since delta V is in what, meter per second, time is in seconds, so units will be meter per second square. And since velocity is a vector quantity, acceleration is also a vector quantity. That is, both magnitude and directions are needed to be taken care of. So this was basically acceleration. Now correspondingly, there is another word of it. It is called deceleration. This word you might also encounter, deceleration. It is basically negative acceleration. That's it, negative acceleration. So when we say acceleration, that means we are basically telling that the velocity is increasing. When we say the word acceleration, so A means that increase in velocity, and negative acceleration, that is minus A, it implies what? Decrease in velocity. That is, whenever like brakes are applied or a vehicle is traveling, the brakes are applied, we say that the vehicle is decelerating. And whenever we accelerate a vehicle, basically we say it's an accelerated motion. That is a velocity is increasing. All right. So this is the difference between acceleration and deceleration. Let us try to understand this acceleration and deceleration a bit more by a graph. All right, so I will draw a graph basically first. Now let me draw a VT graph that will help you to understand more about acceleration and deceleration. So if you have a VT graph, it starts with, let's say, A over here. So we are going over here with the increasing velocity, then the velocity becomes constant. Okay, you can think of a situation like this. Suppose, let's say there is a person home to his office. So initially, so he's going from his home to office. Let us say that. Now, when he's going from office to home to office, I will say it is a positive direction. It's a positive direction. It's up to you, your choice. You can take it negative also, but let's take it as a positive direction from home to office. Now, if the person is going initially at home to office, let us suppose say that. So initially at time t0, basically he was at home. Then he goes with an increasing velocity, which is shown above from here like this. Then after some time, let's say the velocity of the velocity becomes constant. So basically he goes with the constant velocity. When he's about to reach his office, his velocity will continuously decrease in this fashion. Let us say so. Now he stays in the office for some time. Then he comes back now from office to home. He comes back from office to home. Now, when he's coming back from office to home, from home to office is the positive direction. So from office to home, it will be negative direction. That means goes with an increasing velocity, but now it is a negative direction. That's why I drawn below the x-axis. Then after that, the person walks with a constant velocity. You can think of like that. And after some time, when he's about to reach his office, the velocity decreases like this and becomes zero. So this basically tells us that the person, how he is traveling, is like this. All right. So let me tell you few important things in this now. When the person is going from his home to his office, so this we say it is basically, since the velocity is increasing, it is an accelerated motion. I will write A over here. For accelerated motion, I will write A. Why? Because the velocity is increasing. That is the meaning of acceleration. From this point to this point, when the velocity is constant, what is the acceleration? Acceleration is zero. And when the velocity is decreasing continuously, what is the acceleration? It is minus A. It is basically decelerating. All right, that is one thing over here. Now come back to over in the negative direction when the person is going from office to home. What is happening now? The person is going in the negative direction, but its velocity is increasing. Even though it's going in the negative direction, but its velocity is increasing, I will write minus A in this case now. Why minus A? Because even though it's accelerating, but is in the negative direction, that's why minus A. Over here, A is 0. And from when the velocity is basically decreasing, I will write A over here. So that is a very conceptual difference. Okay, a lot of students make mistake in this. Negative A does not always means it's decelerating. Depending on the direction. If the direction is positive, if direction is positive, it implies that negative A means what? Decelerating. And if direction is negative, then minus A will means acceleration. All right, so that is a difference. So negative A does not always mean it's decelerating. You have to think of a direction first and then tell whether it is accelerating and decelerating. All right, so that was basically some important thing about the acceleration and deceleration. So in general, mostly your questions will be based on 85 to 90% of questions will be based on a constant acceleration. So mostly we discuss in general, the acceleration, the question which will be asked, the acceleration is basically called constant. Or if the acceleration is constant, basically there are few equations which will be helpful to solve the questions. But remember, these equations can only be used when the acceleration is constant. These equations are called equations of motion. Equations of motion. Always remember, these are only valid when acceleration is constant. If the acceleration is not constant, then we will be solving those questions with help of graphs. We will be, I will be telling you the graphs, different kind of graphs can be made, and what kind of questions can be asked on the graphs basis on that. So firstly, let us study if the acceleration is constant, what equations or motions are and how they are useful. Equation of motion, basically there are 5 different parameters. Firstly is there letter S, which represents, or X, which tells us about the displacement. This is basically displacement, which is measured in meters. Then we have U, which is basically initial velocity. Initial velocity. Sometimes we also represent this by V naught. This initial velocity, it is measured in meter per second, right? Then we have the final velocity, which is Vf, or we write just V. So it is basically final velocity, right? It is also in meter per second. Then we have acceleration A, which is measured in meter per second square. And lastly is this time. So there are 5 parameters, S or X, this second one, third, fourth, and fifth. 5 parameters are there which describes equation of motion. Now let me write what are the different equations of motions we have. The first equation is Vf equals to V naught plus At. All right, that is the first equation of motion. Then we have X is equal to V naught T plus half of A T square. Then we have V square, Vf square equals to V naught square plus 2ax. And then finally, this is x is equals to v f plus v naught by 2 into t. That is the fourth equation of motion. All right. So these are four equations of motion which will be useful to solve plenty of questions. But again, I'm telling only valid when acceleration is constant. Only valid when a is constant. Acceleration should be constant to use them. Now, if I draw a velocity time graph over here, VT graph, and looks something like this, a straight line. So initially at time t equals to 0, the particle was traveling with the velocity v. The particle velocity was v naught, and after some time, the particle velocity became vf. So after the time, let's say t. So over here, I will just draw time t. So this is time t like this. What is the slope of VT graphs gives? Important, very important point. The slope of VT graph gives what? Acceleration. You must be remembering that I told you that slope of ST graphs is velocity. Now the slope of VT graphs with acceleration. Very important point. So over here, what is the slope? So we can see clearly what is this. This is basically VF minus V naught. What is this? This is this time T naught. What is the slope? Slope is basically this line. So what is the slope? Slope, that is the acceleration, is what? VF minus V naught by T. So if we simplify this, what we are getting? Vf equals to V naught plus At. And that is the first equation of motion. From this point, we got the equation of motion. Now, the second important thing in this basically is the area under the graph. The area basically which we will be considering is this whole area. From here to here. Everything basically have to be taken. So in physics, if an area is asked, basically you have to take everything up till from the x-axis, from x equals to 0. You don't have to take the upper only a triangle over here. You have to take everything. That is the whole area which has been covered. Now, very important point, another point which I'm writing over here is that the area under VT graph gives what? Displacement. Gives displacement, not distance, it is displacement. I will give you some questions. When we do the graphs, I will be discussing more questions on that. So it will be, you will understand what is the difference between distance and displacement from the VT graph. But now it is the area under VT graph, this displacement, very important point. Now, what is the area of this graph? Okay, we can see. So initially we have a triangle. So triangle area is what? Half. What is the base? It is T into height. What is the height over here? Vf minus V naught plus the area of this rectangle over here. So it is what? V naught into T. All right, that is basically the area. This is equal to the displacement S. This total thing is basically displacement S now. So S is what? V naught into T plus half T Vf minus V naught. Now, what is Vf minus V naught? It is At. Sorry, this is half T plus half T, and Vf minus V naught is what? At. So I'll write A into T over here. So finally, it will become S equals to V naught T plus half A T square. And that is the second equation of motion. Now, if you want to drive number third, what do you have to do? In third, you can see third equation of motion. What is missing? Time is missing. So if you place, suppose, let's say I take a time value from here and you put it in this equation, you will get the third equation. Similarly, in the fourth equation, what is missing? Acceleration missing. So rearranging basically acceleration value from the first equation, you have to put in the second equation, you will get the following. So derivations are, not that important, but it's good from the point of view that you will know the slope. So slope of VT graph is A, and the area under VT graph is basically the displacement. These 2 points are very, very important. A lot of questions can be asked directly from that also. So this was basically about the equations of motions and how and where to use this. The last important point I want to tell you that whenever there's a question of equation of motion, you always remember you should have 3 variables with you. I told you there are 5 variables, right? So at least 3 variables which should be with you. So we have 5 variables like S, we have we have X, we have V naught, we have V, we have A, and we have T. From all these, you should have at least 3 to initially begin the question. If there is, you are missing, you are saying that there are only 2 variables, that obviously you cannot apply equation of motion. So you are doing some mistake to judging in the question. So always you should have 3 variables to solve a question. In the next session, we will be discussing how to use this equation of motion and how to solve questions on that. All right. So that's it for today's session. Hope you have liked it. Lastly, I just again want to tell you, please do check Prepaze site and book your free trial class as soon as possible. All right. Hope you liked it. All right, thank you.